Okay, so this is our second day of programming. We're going to take a little closer look at what's going on inside the programs that we've been writing. First thing, just again up at the beginning of the program, we have to put in all of the standard little boilerplate stuff that tells the actual compiler where it can go and grab some extra information. So I would include all of that information at the beginning of every program. Another little thing you can see on this program that I've got here is something called a comment. If you use 2 forward slashes, that actually tells the compiler to totally ignore everything that comes next. So that little title there, boilerplate, that's just me leaving some notes. And it's an expectation as a programmer that you will actually go and leave some notes behind. And you can tell the compiler to ignore what you're writing just by putting a couple of slashes in there. Another thing you'll notice is just some white space. It's an expectation that as a programmer you're going to leave a lot of white space to separate things so that people that look at your code can figure out how different parts are kind of blocked together. And each little block will have some sort of function that it does. Most of the lines that are written in your C or C++ programming are going to finish with a semicolon. That's how the compiler knows that that particular line is done. There are some exceptions. You may have noticed that this one here that says int main with some brackets doesn't actually have any semicolon at the end. It's actually a fairly complicated reason for why it doesn't. It turns out that beginning line there, int main with the brackets, is actually something that defines an entire function, an entire section of code for you, something that we're going to talk quite a bit about a little bit later. It turns out this semicolon at the end, you can think of that as being the last one for this entire function, and that's in some sense where the actual semicolon is for that entire function, saying, hey, we're going to finish everything off. Inside that function, we're going to indent the code. We're just going to hit the tab button when we're coding and then make sure that the lines for that function are all kicked over a little bit. It's an expectation as a program that you'll do that you'll lay out your code in a way where people can look and go, whoa, what's special about those 2 lines? Oh, they're all part of one function. More details about how these functions work. It's actually something we're going to talk about down the road, quite a few days down the road, but you'll just notice a few things here. The int stands for integer, and it explains that this particular function, the main program actually, is something that when it's done is going to kick back some integer value. And in fact, at the very end of the function where it says return 0, that's where this particular function is going to return back. If everything is successful and we can get to the end, it's going to return back a value of 0. And you may have noticed when we were running it, it says, oh, process returned, and then you see that 0 in there. That's the exact same 0 that showed up in that return line. Taking a little closer look at where we were printing stuff out on the screen using that cout command in C++. I'm just kind of tearing that whole thing apart there. At the very end, you've got that ENDL, end L. We're going to end the line. And the little red arrows there are sort of showing that we're going to shove all these things to the output. So hello world goes to the output, and then an end line goes to the output. And then on your screen, it's going to print off exactly like that. Think of that ENDL as being like hitting the enter button, or some people would call it the carriage return button on your keyboard, and that's what kicks it down to the next line. So if you had 2 things that you wanted to display on 2 separate lines, if you don't put the ENDL there, then even though the actual instructions are written on separate lines in your program, they'll actually occur all smushed together. They won't occur on 2 separate lines. So even if you try to put extra white space in your program, the compiler just ignores that, and it would still smush everything together. That's something that we'll actually use it to our advantage later on, but right now you're going to have to go and put some end lines in there in order to kick everything down. If you want to have an extra line in there, in addition to just kicking it down, you want to have a full white space line, then you'll have to put a couple of end lines in there. You can also use the codes. This is actually the way that you would do this in just a C program. The \n is the same thing as doing one of those end lines, and that actually goes inside those quotation marks. And it won't get printed as a /n on the screen. Instead, it'll actually be one of those carriage returns. And you can put a couple in a row if you want to kick it down an extra line. And /t or \t is actually a way that you can do a tab, which can be really nice and quick for doing some formatting. Another little section of the program that we're going to take a look at here now is this part. This is where we're going to start to talk about variables and how we can actually store math values while our program is running. And this section here is actually the first time that we're starting to see some variables. 4 of them, in fact, A, B, C, and D. So let's just kind of talk about what variables are. They're kind of a place where you can store numbers, just like how in an office you've got the little office mailboxes where you can go and store stuff for people, and then they can go and check on it later. Another name that you'll hear for them is pigeonholes, as if you were some sort of carrier pigeon hobbyist and you had these little places for pigeons, and each pigeon needs a little hole. So pigeonholes is another phrase that we like to use all the time. If you actually take a close look at an office mailbox, you'll notice two things. It's got a name so that we know exactly where to go and look, which pigeonhole to check out. And then there are some contents, some stuff that's actually stored in there. And we've got the same thing going on in our code. We're going to have to name the little pigeonhole spaces, and then we can go and put math values into those spaces and then go and grab them later. So in terms of variables, kind of think of it this way. We have to define the variables. We have to tell the computer, hey, I need a pigeonhole that's going to be big enough to store a particular value. It's a good practice to initialize them. It's kind of like being a new employee at an office, and they tell you, oh yeah, here's your pigeonhole, here's your mailbox, and you never really know if the last person has cleared their stuff out. So don't assume that it's empty. There could be just some garbage left over in there that we have to clear out. And then you can go ahead and use it any way you want. You can go put values in, you can go and take a look at the values that are inside them as your program is running. So this section here is actually just defining the variables. It's saying, hey, I need 4 pigeonholes. 2 of them are actually going to be for integers, and 2 of them are going to be for real numbers. It's a good idea to actually comment your codes, so I might want to put a little comment in there that just leaves a note and says, oh, I'm doing some variable declarations. Again, the 2 slashes will tell the compiler to totally ignore everything that comes on that line, and then the next line it'll start to look again. So these left sides of the variable declarations tell the computer how big these pigeonholes need to be. And for now, for today, let's just say that there are 2 kinds. Integers for whole numbers only, including negatives, and floats for real numbers that would have decimals. So that's just a small set of the various kinds of variables that are out there. We'll see some others later for storing things like names and stuff like that. But for today, we'll just go with integers and floats. Then we've got the actual names. Here we've got 4 separate pigeonholes, and we'll just call them A, B, C, and D. So A and B are for integers only, and C and D are for some whole numbers. Now, it's possible, if you want, to declare multiple variables on one line, especially if the variables are kind of logically related together. So you can declare them this way, and the computer doesn't mind at all. After your declarations, it's probably a good idea to start initializing them. You never know what's stuck inside those variables, so have a little section in your code that actually says, all right, let's just go and fill all of these various little spots we've just declared with zeros. That way, we don't have to worry about any junk being left over. It's an option, if you want, to all at once declare and initialize. So I could say int a, so that knows that that tells the compiler I need a little spot to store a, and then right away you can say equals 0. It's an option some people actually like to do. You don't have to do it that way, but some people like to do that. So you can see here I've initialized as well as declared the variables a and b, but for the variables c and d I've only declared them at first, and then just a little bit down below I've actually gone and initialized them. Okay, so I've got a little section of code here that's actually going to not only declare and initialize those variables, but now there are 5 and then 2 more lines that are actually going to go and use them. So I'm just going to kind of walk through how this would work. This line here, a equals 42, is actually going to shove the number 42 into pigeonhole a. It'll make a copy of the number 42 and just position it in variable a so we can access it later. So that's actually just using your code to, in a hard coding way, put a number into a variable. If you want to ask the user for a number and then store it, you could do it like this. I'm going to print on the screen just this blue phrase, enter a value for b, just whatever's in quotes is going to show up. And you'll notice I did not put an end line on that one. And then right afterwards I'm going to say cin. And then whatever they type in on the keyboard, if you think about which way the red arrows are going, that's going to get stored into the variable b. And I've got just a little print screen here of how this actually looked when I ran it. So it typed on the screen, enter a value for b, and then I typed in 45. And so the computer is going to take that 45, and if you think again about the way those red arrows are going, it's going to store that into pigeonhole, into variable b. Notice this space that I've got on the blue phrase there. I said enter value for b, and I deliberately left a space before I put the quotes. And then take a look at how that shows up in the program. It's just a style thing. It leaves a little space before they start typing. Stylistically, it kind of feels good for the user to actually have that space in there. So you might want to think about having that in your code. The next thing, it's going to take this real number, 2.5, a number that has a decimal part to it. It's going to store it into C. And then this one's going to do a little math. It's actually going to take the number 4, multiply it by the value that's currently in C, which I guess is 2.5, and then it's going to divide by 27. And it's going to store the answer in D. So it evaluates what's on the right and then stores it into the answer D. Now, one of the things we're going to talk about next day is why I actually typed 4.0 and not just a 4. It turns out if I had put a 4 there, the computer would actually do something called typecasting, where it would say, oh, I see we're starting off with integers, and it would actually round everything to integers before it actually stores the answer in D. Probably not something you want. And we'll look at a few options for how you can avoid that problem next day. But for now, I'm just going to do a nice easy deal where I just started off by saying 4.0. And then I'm going to actually go and print off the various values that I've got here. So this line that says C out, it's actually going to start displaying some stuff on the screen. The various things that come up on the screen after that, it's going to type out on the screen A equals. And then you'll notice just in the output stream there that the next thing is this variable A. And so it's going to go back and find that pigeonhole that's called A. And it's going to realize that, oh yeah, that right now that value is 42, and it'll display 42 on the screen. And then it keeps on going, and there's that little blue phrase, and B equals, and then the next thing in the output stream is the pigeonhole B. So it will go and find the current value that's in B. And for me, I typed in 45, so out comes 45, followed by an end line. And you can see exactly what happens on the little print screen there, right? It says A equals 42 and B equals 45. After that, I'm going to go and print off the value for D, just using the same plan. So think about the red arrows as being, the direction that things are being shoved. So the output stream gets shoved to the C out to the monitor. So it's going to display D equals, and then the value for D, and then an end line. Again, notice these spaces. If you want to see a space between your D equals and the actual value, then you're going to have to leave that space in the actual blue quotes. Stylistically, it actually looks really nice to actually do that. Next thing we're going to talk about is how to swap variables. Sometimes you have numbers stored in a couple of pigeonholes and you want to swap them just out of one and into the other, and vice versa. Think about a whole bunch of pigeons being inside these pigeonholes, and you're trying to trade pigeonholes for 2 of these pigeons. They don't like being in the same pigeonhole as another bird. So in order to swap 2 of them, you really do need a 3rd pigeonhole in order to pull this off without putting one bird on top of another bird. And in the computer science world, that will actually destroy the first bird and kind of just in its place put the second bird. And we don't want that. So we're going to do something like this if you ever want to swap some variables. We're going to have a 3rd variable. I'm calling it swap. And I'm going to actually go and store the current value for A so I don't lose that information. And then I'll say, okay, into pigeonhole A, why don't we just go and put B? So B goes into A, but it's okay. I've remembered A in that pigeonhole now called swap. And then I can say, all right, swap now goes into B. So whatever's on the right side gets put into the left side. That will work. One thing you do need to be aware of is if you're going to be using that variable called swap, then back up here at the top of the program, you better make sure that you declare it. Otherwise, the compiler will be quite upset saying, hey, you're talking about some pigeonhole that you haven't actually declared yet. So that would have to be declared first before you actually use it. And then if you actually run the code now with that swap little section of code in there, it swaps the 2 variables before it actually displays them. So the upper print screen is what happened before I put in those 3 lines of code, and now you can see what happens after the 3 lines. And it's actually just traded places with those 2 variables that we've got there. One last little thing here, or maybe 2 last little things, just about how the assignments work. These are typical assignment statements that you're going to see inside your code. And the general plan, whether it's the top one or the bottom one, the computer is going to evaluate the stuff that's over on the right-hand side. So it will do the math that's actually happening on the right-hand side, and then it will take whatever that answer is, and it's going to store it into that pigeonhole. That's even true for the bottom line. Now, in math class, it wouldn't make a lot of sense to say A equals A plus 1. There isn't any number that does that. But in computer science, it's going to take whatever the current value for A is, in whatever pigeonhole is called A, it will add 1 to it, and then put it back into that pigeonhole. And that's called incrementing. So if there was a number like 27 inside a pigeonhole, and you needed it to update to become 28, that's exactly the line that you would put in. Last little bit here, just some differences between C and C++. For having numbers come into the program from the user in C++, we can just use cin, and then the red arrows say, all right, from the keyboard, we will go and store them in some pigeonholes. If it's in C, it's a little bit more entertaining to try to figure out how to get that to work. If you want to input an integer, it's going to have to look like that top line. And if you want to input a float number, it's going to have to look like the bottom line. And that little %i lets the computer know that I'm expecting to see an integer. And then when you see it, go ahead and store it into that place that's actually called b. And then the same thing down below for doing float values that have decimals to them. When it's time to actually put some stuff out to the screen, in C++, we can just use cout. And again, always think about the red arrows as the direction of the stream of information. And you can use those couts with the lines there, the value for b is, and then the b and the n line in order to send all of that to the output, out to the monitor. If you're going to do that in C, it's again a little more entertaining. You'll notice in the blue quotes there, I've got the value for b is, and then there are some interesting codes. The %i says, all right, in a minute I'm going to tell you about an integer, and then put the value right there. And then that little \n says, oh yeah, by the way, when you're done, how about a new line? And then there's a comma, and then there's b. So that will tell the computer now, oh, okay, that spot where it says %i, you were probably wondering, well, what should I print there? Oh, go and look at pigeonhole b, find the value, and display that right where the %i is. And then the very last line, the exact same thing for floats. It's going to print on the screen the value for c is, and then it sees that %f, so it knows, okay, after we're done, after a comma, there's going to be this value. And it turns out it's going to be c, as you can see. And then the \n will tell it to do a new line. So that finishes, and then the comma, and then the actual information about which variables to go and look at. So a little bit of a difference there between C++ and C for having numbers go into the machine and having numbers come back out. And that pretty much wraps up the information that you need to know for day 2.